please make him feel really welcome, Dr Troy Gaston.
Thank you, everyone. Are we ready to do some science? Now, I know that some of my ex-students in the audience are, well, second worst and third worst students that we had. Just a few questions straight up. Who goes fishing? Now, who actually catches something? Who likes being near the water? Who likes being on the water? Who doesn't like brown, stinky, oozy mud and water? All of these things that you guys like to do, we would call cultural ecosystem services. Tuggerah Lakes is well known for that. It's also well known for some of its issues. The work that I like to do as a scientist, and I am a scientist, don't hold it against me, I am a geek, I'm a nerd, that's fine. I make a great living out of it. I get paid to go fishing as part of my job. We need to understand these cultural ecosystem services, but we also need to understand how the system actually works. Now, in New South Wales, we've got 137 estuaries. Every single one of them is different. So we can't pigeonhole how estuaries work. We need to look at how the individual systems work. Now, we understand that the estuaries are nursery grounds for fish. They're what I would call a mosaic of habitats. There's lots of different stuff going on. The estuaries also provide refuge from predation. There's lots of places to hide. Now, these estuaries actually have what I would call food and housing availability for anything that lives in the ocean, but we actually have a food and housing crisis in our estuaries, and I'll talk about that in a little bit. Then there's the things that we want to catch and eat. Now, they either spend part or their entire life cycle in the estuary. As an example, we don't know what actually causes blue swimmer crab and mud crab growth and, I guess, recruitment variability when they actually spawn, how many survive, when they're going to spawn, when they're going to survive. We're just embarking on that now. So there's so much we don't know, but fishermen know where to go and catch them. The issue we have in New South Wales is habitat loss. Now, I've heard a lot of comments that our fisheries are poorly managed. That's not true. Australia manages its fisheries exceptionally well in a global context. We have a lot of Marine Stewardship Council certification for our fisheries. But as an example, we've lost over 60% of salt marsh. We've lost over 70% of seagrass. And we've seen a small increase in mangrove in our estuaries in New South Wales. Now, the example here is the Hunter River. Just go north a little bit. The red area represents what we've lost in the Hunter River system. I just heard that's terrible. Yes. Who wants to hazard a guess who caused that? In every estuary, we have a range of different habitats, and this is what supports productivity. It's having that food, having that housing. In the Tuggerah Lake system, we have seagrass. We've got a touch of salt marsh. We've got a couple of mangroves that pop up now and then. We've got lots of mud. Estuaries need mud. It's an integral component. We're not going to get rid of it. We need it there. It's where the prawns go and hide. It's where a lot of fish feed. It's where a lot of, we'll get some green slime growing. That's a healthy food resource. What we don't understand is what is the most important habitat in a system. How do we work out what is most important? And if we can rank that importance, we know where to target our on-ground works. That's the stuff that I do. I want to know, why is that fish doing that? We're also now seeing a whole lot of targeted habitat restoration. And if you're trawling the United Nations website, like I quite often do when I get bored at home and it's nighttime, there's now the decade of ecosystem restoration. We know we've caused this massive degradation. What are we going to do about it? So from a global stage, we're now seeing this decade of ecosystem restoration. We know we can get huge gains in ecosystem productivity if we get the system back to how it was. We can even prioritise what we do from a fishery perspective, because recreational fishing in Australia is a huge business. A third of our population engage in recreational fishing. I love to recreational fish. My granddad taught me how to fish. I want to keep doing it. I want to see you guys keep doing it. I use a little bit of nerdy science. I use a natural chemical tracer. I call it stable isotope ecology. You can call it hocus pocus black box stuff, but it works and it's proven. We've been using it for decades. I can tell you which is the most important habitat or food or area in the Tuggerah Lakes system that produces most of our fish, prawns, crustaceans, crabs, whatever it is you want to know. And that's what we need to know so we can actually improve the productivity in our systems. So the work I've been doing across New South Wales, and this is with DPI, OEH, lots of local councils, because the councils are on the ground doing a lot of the work now, because it's devolved down from the state. We want to know what supports production, and I call that secondary productivity, knowing that's the fish and crabs, stuff you guys want to catch. And also from a prawn perspective, because prawn fishing is one of our biggest industries in New South Wales, where do the little baby prawns go and hang out? We catch them on the run out. That's easy. Just take a torch and a net. You can get out of Bunnings and get that stuff. But where do the little prawns go and what makes them most productive? That's what I'm interested in. So what I've been doing is a lot of fishing. I'm not the best at it, but I'm also not the worst in our research group. There's a reason I'm a scientist and not a fisher person. All these species we're looking at, and we collect all the different plants and habitats that we have in a system. Then we do this natural chemical tracer. This is what it looks like. Let me quickly explain it to you. On the x-axis, we deal with carbon. It's really, really important. On the y-axis, left-hand side, we deal with nitrogen, also very important for growth. All the different plants here, they sit in different spots. Allows us to track where it goes into animals. That's the underlying assumption that I use for my science. All these habitats have different natural chemical traces that we can use. I then throw it into our fish. But how much goes from each of those habitats goes into those fish? That's what I want to know, because then we can target on-ground actions. This is from the hunter. Far right-hand side is salt marsh. Far left-hand side is mangrove. The closer the fish is to a particular chemical signature, that's what it's been eating. Now, we know flathead don't eat plants. They're ambush predators. They love fish. But the fish they've eaten have been living in salt marsh. That's what I want to know. So we can go right down to the bottom of the food chain and see where they've been going. So just as an example, we've got sea mullet, 50% of their diet comes from salt marsh. Blue swimmer crab, 58%. Flathead, 63%. Salt marsh is the habitat we have least of in New South Wales now. So we actually have a food and housing crisis for our estuaries. So what can we actually do? Given that salt marsh is the smallest aerial extent, it's the most important food-wise. It's actually the tastiest. I don't know if you've ever tried it, but it's far tastier than eating a mangrove leaf or a seagrass blade. If it is disproportionately more important, does this apply to all 137 estuaries in New South Wales? So the management implications, we have to act now. We know where salt marsh wants to live, so we can't mow it. We have to let it be able to grow up the shoreline as our sea levels rise. Whether you believe in climate change or not, our sea levels go up and down every hundreds of thousands of years. Salt marsh needs somewhere to go. We need to protect and restore this habitat. But what might help is how valuable that habitat is. So we've done a few back of the beer coaster calculations, and literally it was on the back of a beer coaster. You take this degraded habitat, which is a renovator's delight, we restore it, we get it back to salt marsh, the prawns are coming in, they're looking to buy, they're looking to eat. We've worked out that for each hectare of salt marsh habitat we put back, we can earn $25,000 a year just for prawns. That's one species. Let's add in bream, flathead, blue swimmer crab, mud crab, all of those species. Massive increases in productivity and economic return just by getting our natural habitats back. That's what the science tells us. I'm going to handball it off to the governments to try and figure out how to actually make that happen, but it's actually going to fall back to us for allowing these habitats to return naturally in our system. That's me, that's my science. Thank you very much.